Hello, my name is Grace Bello. I'm an archaeologist at the Northeast Archaeological Resources Program of Region 1 for the National Park Service, or more affectionately known as NARP. I've worked at NARP since December of last year, but have been with the Park Service for a little bit under 2 years now. During my time with NARP, I've worked on a few different geophysical surveys, but the survey that has been the most exciting so far was the investigation at the White Hill Field Quarters that took place back in March at Petersburg National Battlefield in Virginia. Before I talk about the Field Quarters investigation, what is a geophysical survey? For us at NARP, we use geophysical surveys as a non-invasive or non-destructive method, which uses ground-based physical sensing techniques to produce a detailed image or map of the underground area that we are investigating. The survey at the White Hill Field Quarters was one of the more exciting projects I've worked on, as we utilize multiple survey methods that aren't always used in consort with one another. We used STP surveys, which is basically a small excavation unit that we can excavate over a large area in a quick amount of time, in combination with metal detecting surveys and geophysical surveys to maximize the possibility of identifying these field quarters that would have been associated with a 19th century plantation at the site. As field quarters can be sort of ephemeral structures and sometimes hard to locate, with just one survey method, we use the STPs, metal detecting surveys to identify artifact distributions and overall site boundaries in combination with geophysical surveys to identify underground features. Together, these methods enabled our team to efficiently survey a large site area and possibly identify evidence of the occupation of the site associated with the field quarters, as well as evidence of occupation of that landscape before and after it was used as a plantation. One of the geophysical survey methods we used was ground penetrating radar, or GPR. This method utilizes electromagnetic waves that measure contrasting dielectric permittivity and different electrical conduction properties. Basically, GPR is used to measure a material's ability to conduct and pass this type of electromagnetic wave. As this wave comes in contact with a material, it is reflected, and the time, strength, and amplitude of that reflected wave is measured by the unit that you can see here. This reflection occurs when the wave passes between two materials with contrasting dielectric properties, such as between wet and dry soil or between wet soil to a foundation wall. This type of data is then collected by walking parallel transects to collect multiple vertical profiles of the transect. These profiles can then be combined to create a three-dimensional image, which we use to estimate depths of underground anomalies or features. This GPR data plan shows one horizontal slice of those combined vertical profiles at around a half meter below the ground surface. The white areas in this plan show locations of strong reflections of the electromagnetic wave, and the dark areas show weaker reflections. The other geophysical method that we used during the survey is electrical resistance. Here we use a resistivity survey to map changes in resistance to electrical current, which can be different based on soil saturation or based on different formation processes of the soil. Resistivity surveys use electrical currents to identify contrasting electrical characteristics of underground materials, which we use to identify high and low res features. This plan shows the results of the resistivity survey at the field quarters, which shows the opposite color grading of the GPR survey. Here, the dark areas represent high res and the white areas show low res. The high and low res areas shown here could be different based on the level of compaction or based on a high amount of resistive materials that are within the soil matrix, such as large artifact clusters. These two plans can help inform where future investigations will occur and could possibly indicate areas that were highly compacted from activities in those spaces or from road surfaces. These anomalies could also indicate demolished structures or remnants of foundation boundaries. Here on the left, you see our GPR survey plan, and on the right, you see our resistivity survey plan. And these circled areas are possible locations where we might want to revisit in the future to archaeologically excavate these areas to identify what these anomalies are. These geophysical survey methods were used at Petersburg because each method is sensitive to a different type of earth property. So our selection is very specific and is not only based on the site composition, but is also based on the archaeological features that we are actually searching for. Thank you for joining me for this discussion of geophysical survey methods.